Hey 301ers, welcome to video 2, where we will be discussing the factors affecting the cardiovascular responses that we've talked about in the first video. So basically, when we look at the cardiovascular changes that occur with exercise training, we're looking at the final outcome of increasing aerobic performance. And this is basically going to be a culmination of our ability to deliver oxygen to skeletal muscle, and this is going to be a result of our pulmonary system. Let's make that U look a little bit better. Pulmonary system, where we can get O2 from the atmosphere, as well as the cardiovascular system to deliver that O2 to the muscle. And then we also need the ability for our muscle to consume that O2. So that means we need to be able to extract the O2, and we need to be able to utilize it with our metabolic pathways. So that includes the citric acid cycle and the electron transport chain, which we know is highly dependent on very good functioning mitochondria. So there are several influential factors that are going to determine how well this occurs. And one is the initial level of fitness. For instance, if we have someone that is unfit and we start them on a training program, what kind of differences would you expect that person to exhibit compared to someone that has been training for years and years and years? Well, there's a really cool chart that you can look at. And this is actually in reference to looking at how much training you need to increase someone's adaptations. But this also works for looking at what are the initial changes that you would experience depending on your initial level of fitness. So for instance, if we take an individual that is at rock bottom with their running performance, if we're talking about running as an aerobic training modality, and we see that we increase the amount of training just a little bit to this level here, you can see that their racing performance increased by quite a bit. So it increased from here to here. But what if you took an individual that was maybe at this level of racing performance and you increased the amount of training from where they're currently at to here? You can see that it's a much smaller increase. And what we generally call this, as we see that you have a certain amount of increase in the amount of training, either through volume or intensity or both, as you get more and more trained, you have less of a response to the increase in training, even though at these levels over here, you are really training a lot. We call this the law of diminishing returns. Sad but true. So the more fit you get, you have to work a lot harder to obtain any extra adaptations to exercise training. What else influences our aerobic adaptations? Well, training frequency. It's kind of interesting that generally you can see improvements with as little as 3 days per week. Not too bad, right? And in fact, some places, or I should say some research, has stated that there might be some training adaptations that can occur even with 1 day per week. These are generally with sedentary individuals. Of course, people that aren't working out too much don't need much amount of training volume for them to increase their aerobic adaptations. And then if you look at some other research has shown that if you train 4 to 5 days per week, you actually see just marginal or small increases in physiological improvement. So if we're looking for aerobic adaptations, if we increase how often we're training to 4 to 5 days per week, we're not going to see that much difference than we would see at 3 days per week. But what you might see, depending on what kind of outcome you're looking for, maybe aerobic performance is not that big of a deal for you, but if you are looking at increased energy expenditure, which would have an outcome on weight loss, then exercising more days per week will most likely have some sort of outcome on that. So it depends on what kind of outcome you're actually looking at obtaining. Okay, so moving on, we look at training duration. Training duration is how long you're actually training. And we've actually looked at a few studies that have examined this, and one specifically from your book looked at swimming. Very interesting study in which they took one group, and these swimmers were training 1.5 hours per day. A lot of training. And then you had another group that was also doing 1.5 hours per day, but they were doing it twice a day. So they were training 3 hours per day. And you know what? They found no difference in swimming power, swimming endurance, or even performance time. So that is definitely telling us that there is probably some sort of ceiling on training duration, on its impact for certain types of performance outcomes. And this is probably dependent on sport, as well as going back to initial level of fitness and how long someone has been training. Now, if we look at training intensity, I am going to star that here, star that here, star that here, and star that there, because training intensity is the most critical variable that you can look at in regards to factors that affect cardiovascular responses to exercise training. And remember, intensity is reflecting the energy requirements needed to support a certain level of exercise. Many different ways that you might be able to express training intensity. You guys know some of these. Maybe looking at calories expended. Maybe looking at power output. How about percent VO2 max? Or even percent heart rate max. And we can even look at multiples of metabolic equivalence. And remember, that's our looking at multiples of our resting metabolic rate. One met is your metabolic rate when not doing anything. Now, the thing that we're looking at when we do understand training intensity is that it doesn't necessarily always have to be super intense. You can do something what's called conversational exercise, in which you can exercise at such an intensity level where you can still hold a conversation. And this gets you to an intensity that you are able to get to that sort of minimum training intensity needed to get adaptation without going too hard. And if you go too hard, you know the implications for that is you're just not going to be able to train long enough to get those adaptations to occur, because you are starting to tap into your anaerobic metabolic pathways to support you. Now, this threshold for what training intensity needs to be hit before you start seeing these aerobic adaptations is probably dependent on things like age, fitness level, how long you've been training, so on and so forth. So finding a training intensity that's going to have a balance between stimulating your aerobic pathways as well as anaerobic pathways, but allowing you to get enough training duration as well as training frequency to get your full aerobic adaptations is the balance that you will need to find out for each individual. Last thing that we're going to look at is genetic potential. And no doubt about it, someone's genetics is highly important in determining what sort of aerobic adaptations you're going to have with exercise training, because that's building everything that is going to be adapting to exercise, such as the functioning of your heart, how your blood vessels form, of course, the different parts of your skeletal muscle and how they work together to utilize the oxygen that you're delivering to it. And in fact, individuals have studied this. A recent research article, 2013, looking at the genetic influence on athletic performance. Guth and Roth here have some key points that they looked at. You might find very interesting. And their key points are athletic status, as well as many cardiovascular, endurance, and muscular phenotypes, are highly heritable, supporting a role for genetic factors in the achievement of athletic success, probably what you already thought. And in fact, there are some very important genes that they have found that are associated with endurance performance or power-oriented performances. And they find that if you have a certain form of these genes, then you probably have a higher likelihood of being a better endurance athlete or a better power-oriented athlete. Some of these genetic variants may alter injury risk and or post-injury outcomes, so your ability to rehab from an injury, although there's definitely a lot more research going on there. And here's the kicker. No genetic variant, so not this gene, or any other gene that we know of today, has reached the level of predictability for athletic success, meaning that just because you have this gene or that gene does not allow us to predict whether or not you're going to be a successful athlete, only giving us a small hint of what your athletic potential might be. All right, guys, I hope this was a pretty exciting video for you. So you know your genes have something to do with how well you're going to respond to exercise, but there are much more variables involved with that, such as the variables that we talked about in this particular video module. All right, thanks, guys. I will see you in the final video coming up in video 3.